All right, so at the top of the paper, I want you to go ahead and put a large title, Pythagorean Theorem. Okay. Pythagorean is after the mathematician Pythagoras. So this whole idea was named after him because he discovered it. It only has to do with right triangles. So if it's not a right triangle, then we don't use the Pythagorean theorem with it. Remember that a right triangle is a triangle that has that 90-degree angle. Hypotenuse, we'll start with that first. The hypotenuse is this side length here, which is across from the 90-degree angle, and it's always longest, okay? So we're gonna write that it is the longest side of a right triangle, and it is across from the 90-degree angle. We also like to use the letter C for it. Okay, and over here on this diagram, I want you to label that this side length is the hypotenuse. All right, for the legs, okay, those are the sides that are touching this 90-degree angle, so it's these two side lengths here. And we like to use A and B for those. So the sides touching the 90 degrees, they actually make that 90-degree angle. And we like to use A and B for those. And it doesn't matter which one's A and which one's B because they both share that same relationship that they're shorter than the hypotenuse. So if this is A and this is B, those are legs. All right, in our Pythagorean theorem, A squared plus B squared equals C squared. And what that means is that if you take the two legs, whatever that number is, and you square them and add them together, it will equal that C squared, or this side length squared. And we'll talk more about that in a second. All right, now the converse is just another way of saying the two legs squared and added together is equal to the hypotenuse squared. It's just reversing it. So all that means, if the square of the length of the longest side, that's the hypotenuse, so longest side, of a right triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. It will only work for a right triangle. And it being a right triangle means that it has a 90-degree angle. Okay, and we are going to illustrate this using area as our proof. Okay, so the whole thing is A squared plus B squared is equal to C squared. We're going to start with a 3, 4, 5 triangle. So we're going to go in the middle of our grid here, and I want you to outline a length of 3 and then a length of 4 connecting it. So it looks like an L. It's creating that right angle. And then you're just going to finish this up by closing it so that it's a triangle. So you're just connecting those two together. So this length is 3 and this length is 4. And so that means that A and B are 3 and 4. So this is 3 squared plus 4 squared should equal, and now we're going to find out what C is. So I'm still just putting C squared down. And to find that, I want you to take the side length of 3 and turn that into a square. So now it's a 3 by 3 square. And just shade that in. And then the side length that has the 4, turn that into a separate square. So it's a 4 by 4 square. And you would shade that in lightly. And so 3 squared, or a square of 3, is how many boxes? If you look closely and you count those boxes that are shaded in, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And what is 3 times 3? 9. And the same thing would happen with this 4 by 4 square. 4 times 4 is 16. Okay? And 9 and 16, because we said the sum of those. So 9 and 16 is how much? 25. So 25 is equal to c squared. And you might be wondering, where is c squared? Well, if we turn this into a square, that's where c squared is. We can just sketch it because it doesn't match the direction of the grid. So we're trying to find out what is this length if we know that this is a square. Well, if the whole thing adds up to 25 boxes, then how many boxes are the side lengths? And to answer that, what's the inverse operation of squaring a value? We learned this the second week of school. So the inverse operation of squaring is to square root. So then we're going to take the square root of 25. And that's going to give us what c is. So what is the square root of 25? 5. And that's because 5 times 5 is 25. So I know that the side length of this square is 5. Now we could, this is a long way of explaining it, but what we could have done is just gone ahead and done 3 squared plus 4 squared directly into our calculator, like this. And you see it gives us 25, and then we just take the square root of that, okay? Or we just, if they give us all 3 numbers, we just take that number and square it to see if it equals that, which is what we're going to be doing today. So we'll get the 3 numbers, and we're going to check that the 2 smaller ones squared and added together equals the bigger number squared, okay? So looking at our first example with the green triangle, which one has to be our hypotenuse? The largest number, right? Which one's the largest? 29. So circle that and label it the hypotenuse. Okay, so if the hypotenuse is 29, then that means that these other 2 are a and b. Okay, so we're going to do a squared plus b squared and check to make sure that it equals c squared. So now, 20 squared plus 21 squared should equal 29 squared if this is a right triangle. Okay, so I would go ahead and type in the calculator 20 squared plus 21 squared. Just like that. It equals 841. And then type in 29 squared to make sure that that is equal to 841. And it is. So if they are equal to each other, then yes, this is a right triangle. Okay, so then the next example. We have 5, 6, and 10. Which one has to be the hypotenuse? 10. So circle that, that's our hypotenuse. And so now we're going to do 5 squared plus 6 squared and check to see that it equals 10 squared. Well, what is 5 squared and 6 squared? Yeah, 25 and 36, which is 61. And does 61 equal to 10 times 10, or 100? No, so I want you to put that it's not equal, and no, this is not a right triangle. We're just proving whether it is or is not a right triangle.